So to understand this concept, let us take few examples. Okay, find Fourier transform. Okay, so find CTFT of, let us say, first signal x of t. Okay, so first signal let us take to be 1 by 1 plus jt, so which is simple. So this fellow will have what as Fourier transform, that is the question. Okay, so if you let us apply duality property. So if you look at duality property, so where should we start? We should know which signal will have 1 by 1 plus j omega as the Fourier transform. So that is the hint to use the duality property. So what is that we have to do? Look for a signal. Okay, so look for a signal which has what? 1 by 1 plus j omega as CTFT. Okay, so that we already know, right? So which signal will have 1 by 1 plus j omega as the Fourier transform here? E power minus t u of t. Okay, so let us start with this signal. So x of t equal to e power minus t u of t. So this fellow will have x of j omega, which is equal to 1 by 1 plus j omega as the Fourier transform. But if you replace omega with t, what will happen? X of jt would be equal to how much? Omega is replaced with t, so you will get 1 by 1 plus jt, which is same as our required function. So this fellow will have what as Fourier transform according to duality property? This fellow will have 2 pi times small x of minus omega, which would be equal to 2 pi times x of t is what? E power minus t u of t. If you replace t with minus omega, you get 2 pi e power omega multiplied with u of minus omega. So 1 by 1 plus jt will have 2 pi times e power omega u of minus omega. So what is crucial step here? You have to always look for a signal which will have this function as the Fourier transform by replacing t with omega. Okay, so again, to understand this, we will take few more examples. Okay, yes, so let us take second example to be, let's say, find the Fourier transform of second function 2 minus j omega. Okay, we'll or 2 minus jt. Okay, so we want Fourier transform of this signal. So where should we start? Start with which signal? Start with which signal will have 1 by, start with the signal which has 1 by 2 minus j omega as CTFT. You have to start with the signal which will have 1 by 2 minus j omega as the CTFT. So which signal will have 1 by 2 minus j omega as a Fourier transform? We have already seen that. Who is that here? The x of t should be e power 2t u of minus t. Correct? So e power 2t u of minus t will have x of j omega as the Fourier transform, which is 1 by 2 minus j omega. Now again we replace omega with the t. So what do we get? X of jt, which is equal to 1 by 2 minus jt. So this fellow will have what as Fourier transform? 2 pi times small x of minus omega, means wherever there is t, replace with minus omega. You get how much? 2 pi times e power minus 2 omega u of omega. So this fellow will have our original signal 1 by 2 minus jt will have 2 pi times e power minus 2 omega u of omega as the Fourier transform. Okay, so what is the crucial step? Again, you should always look for a signal which will have the given function as the Fourier transform. Okay, so we will take third signal. Let us take third signal to be, let's say, 1 by 9 plus t square. So we want to find Fourier transform of this signal. So clearly should start with what? We should start with, okay, so we should start with a signal with CTFT 1 by 9 plus omega square. Okay, so if you remember, for the signal e power minus 3 mod t, this fellow will have what as Fourier transform? 6 divided by 9 plus omega square, right? So if you multiply with 1 by 6, so let us take that signal. Okay, let us take x of t to be 1 by 6 e power minus 3 mod t. So this fellow will have what as Fourier transform? Yes, because 1 by you are multiplying with 1 by 6, this fellow will have x of j omega, which is equal to 1 by 9 plus omega square as the Fourier transform. So we have to look for a signal which will have 1 by 9 plus omega square as the Fourier transform, and we know that signal to be how much? 1 by 6 times e power minus 3 mod t. Now let us follow the duality property. So what is x of jt? Definitely that is 1 by 9 plus t square, which is same as our signal, our required signal, right? What is our required signal? We want Fourier transform of 1 by 9 plus t square, and that is what we have got here. Okay, so this fellow will have what as Fourier transform? Again, using duality property, you have 2 pi times x of minus omega, which is equal to 2 pi divided by 6, and if you replace t with minus omega, you get again e power minus 3. Modulus of minus omega is modulus of omega. So this simplifies to pi by 3 times e power minus 3 mod omega. This would be the Fourier transform of which signal? 1 by 9 plus t square. Okay.